Alright, so we're going to look at section 6.7, which is hyperbolic trig functions. And so the first thing we're going to look at is the different definitions of our hyperbolic functions. Alright, so we represent hyperbolic functions by putting in the letter h in front of our variable. So hyperbolic sine would be sine h of x. And what that is actually equivalent to is e to the x minus e to the negative x divided by 2. We do the same thing for the hyperbolic cosine, except the hyperbolic cosine function is equal to e to the x plus e to the negative x divided by 2. Just like tangent is sine over cosine, the hyperbolic tangent is the hyperbolic sine divided by the hyperbolic cosine, which, if you actually work that out, is equal to e to the x minus e to the negative x divided by e to the x plus e to the negative x. And then for our last three, we have the hyperbolic cosecant function. Remember that cosecant is 1 over sine, so hyperbolic cosecant is 1 over the hyperbolic sine of x, which is equal to 2 divided by e to the x minus e to the negative x. The hyperbolic secant is equal to 1 over the hyperbolic cosine, which is equal to 2 divided by e to the x plus e to the negative x. And the hyperbolic cotangent function is equal to the hyperbolic cosine function divided by the hyperbolic sine function, which equates to e to the x plus e to the negative x divided by e to the x minus e to the negative x. Okay, so let's look at actually evaluating then a hyperbolic function. Yep. Okay, so Mark, what's the formula for hyperbolic cosine?
E to the x plus e to the negative x over 2.
Perfect. Okay, so in this case then, our x is equivalent to 4 because we're trying to find the hyperbolic cosine of 4. So then this function would equate to e to the 4 plus e to the negative 4 divided by 2. And then put it in your calculator. Make sure you put the top in parentheses when you put it in your calculator. All right, and Kira, what do we get?
27,
3.
308.
Perfect. So 27.308. Okay, so evaluating them is pretty simple. The second part of what we're doing is we're looking at the actual identities for them. Okay, so the first identity says that the hyperbolic sine of negative x is equal to negative hyperbolic sine of x, which just means you can pull your negative out front. Or the second identity, the hyperbolic cosine of negative x is equal to the hyperbolic cosine of positive x. What that means is that negative and positive x's are going to give you the same solution. So if you have a negative x, just change it to positive to evaluate. For the third identity, the hyperbolic cosine squared minus the hyperbolic sine squared is going to equal 1. Nope. Nope. For number 2, it doesn't matter if the x is positive or negative. You'll just evaluate it as a positive. That's what that means. For the fourth, fifth, and sixth hyperbolic identities, we have for number 4, 1 minus the hyperbolic tangent squared is equal to the hyperbolic secant squared. For number 5, we have the hyperbolic sine of any two functions added together, x plus y, gives you the hyperbolic sine of x, the hyperbolic cosine of y, plus the hyperbolic cosine of x times the hyperbolic sine of y. And for number 6, the hyperbolic cosine of any two functions added together, x plus y, is equal to the hyperbolic cosine of x times the hyperbolic cosine of y, plus the hyperbolic sine of x times the hyperbolic sine of y. Alright, and the third thing we're going to look at today is the derivative of hyperbolic functions. When deriving the hyperbolic sine function in terms of x, it will equal the hyperbolic cosine function. And when deriving the hyperbolic cosine function in terms of x, it will equal the hyperbolic sine function. Or number 3, when deriving the hyperbolic tangent function in terms of x, you get the hyperbolic secant function squared. When deriving the hyperbolic cosecant function in terms of x, you get negative hyperbolic cosecant of x, hyperbolic cotangent of x. When deriving the hyperbolic secant function in terms of x, you get negative hyperbolic secant of x times hyperbolic tangent of x. And lastly, when deriving the hyperbolic cotangent function in terms of x, you get negative hyperbolic cosecant squared of x. Okay, so let's find the derivative of the hyperbolic cosine of the square root of x. Okay, well, when deriving the hyperbolic cosine function in terms of x, since this is like two separate functions, we're gonna derive the outside times the derivative of the inside. So, Mikey, what's the derivative of the hyperbolic cosine function?
Oh,
the hyperbolic sine function, right? Yep, okay, so the outside would become the hyperbolic sine of the square root of x times the derivative of the inside, and my inside is just the square root of x. And the derivative of the square root of x is 1 over 2 square root of x. So then when I simplify that, I put this over 1 and I multiply my fraction straight across. Hyperbolic sine times 1 just stays hyperbolic sine. So I get the hyperbolic sine of the square root of x. And 1 times 2 square root of x stays 2 square root of x. So the derivative of the hyperbolic cosine of square root of x is the hyperbolic sine square root of x divided by 2 square root of x. And the last couple things we're going to look at is inverse hyperbolic functions. Yes. And we're only going to look at our 3 main trig functions for those, for the first part. So the inverse sine, inverse cosine, and inverse tangent functions. Okay, so for number 1, the inverse hyperbolic sine function is equal to the natural log of x plus the square root of x squared plus 1. The inverse hyperbolic cosine function is equal to the natural log of x plus the square root of x squared minus 1. And the inverse hyperbolic tangent function is equal to 1/2 times the natural log of 1 plus x divided by 1 minus x. Alright, and then let's look at the derivatives of our inverse hyperbolic functions. So the derivative of the inverse hyperbolic sine function in terms of x is equal to 1 divided by the square root of 1 plus x squared. The derivative of our inverse hyperbolic cosine function in terms of x is equal to 1 divided by the square root of x squared minus 1. The derivative of our inverse hyperbolic tangent function is equal to 1 divided by 1 minus x squared. And then our last 3 trig functions. The derivative of the hyperbolic cosecant, the inverse hyperbolic cosecant function in terms of x is equal to negative 1 divided by the absolute value of x times the square root of x squared plus 1. The derivative of our inverse hyperbolic secant function is equal to negative 1 divided by x times the square root of 1 minus x squared. And the derivative of the inverse hyperbolic cotangent function in terms of x is equal to 1 divided by 1 minus x squared. Okay, so the last example we'll look at is finding the derivative of our inverse hyperbolic tangent function of sine of x. Okay, and so using our chain rule, we'll take the derivative of the outside, so the inverse hyperbolic tangent of sine of x, times the derivative of our inside, so times just the derivative of sine of x. Sine is what's on the inside of our function. Alright, so Kira, what is the formula for the derivative of the inverse hyperbolic tangent function? 1 minus x squared. Okay, so my formula is 1 over 1 minus x squared, but in this case my x is actually the function sine of x, so this would be 1 over 1 minus sine of x squared. Okay, and who remembers what the derivative of sine of x is? Just regular sine of x, not our hyperbolic sine. Anybody remember? Cosine. Nope, it's positive. Okay, so cosine of x. Yep, sine turns into cosine when you derive it. So I end up with 1 over 1 minus sine of x squared times cosine of x. So then if I go ahead and simplify and make this cosine be over 1, move my square to in between the x and the sine, I get 1 times cosine is just cosine of x. 1 minus sine squared x times 1 is just 1 minus sine squared of x. That's it. Okay, so now that you know everything you need to know about hyperbolic functions, your assignment is page 467, numbers 1 through 6, number 23, and 30 through 35.